Hi, and welcome to this content bite which details the different types of thermodynamic system. These need to be understood as the thermodynamic variables we need to consider depend upon the types of system we have. We have two things to consider when looking at thermodynamic systems, the system and the surroundings. Together they are called the universe. An example of a system is your reaction on the bench or the contents of a calorimeter. The surroundings is everything else around it. The first type of system we are going to consider is an isolated system. An isolated system is one where there can be no exchange of either matter or energy in any form between the system and the surroundings. It is the simplest system we have, and although the fact that there can be no exchange of matter or energy, and therefore may at first sight appear boring, they are fundamental to our understanding of thermodynamics. You may consider an isolated system to be the contents of a perfectly insulated stoppered flask. The common definition of the first law of thermodynamics uses an isolated system. The second type of system I am sharing is an open system. An open system is just that, open to the surroundings, to both an exchange of matter and energy. Therefore, we can add or take away context, mix in something new, put in energy to heat the system up, allow it to expand, or just allow it to cool down to room temperature. The classic way to think of an open system is just a beaker on a bench waiting for you to do stuff. Although open systems are describing what we actually do in the lab, thermodynamically we don't usually think about them. Instead, we tend to think about simpler models such as a closed system. A closed system has a fixed amount of stuff. I can't add or remove matter. But by having a movable diathermic wall, we can have energy exchange in two different ways, heat and work. We will learn more about these two forms of exchanging energy elsewhere in the course. However, I will note here that usually when we consider work, we are considering expansion work, although there are many different types of work within thermodynamics, and a closed system allows any type of energy transfer in the form of work to occur. Secondly, I will note that the transfer in energy in the form of heat via the diathermic wall should not be impeded by this boundary in a truly closed system. But as long as the system and its surroundings are allowed to come into thermal equilibrium, the boundary doesn't really need to be considered. Our final type of system is an adiabatic system. The term adiabatic comes from the Greek for impassable, adiabatos, and this system is separated from the surroundings by an adiabatic wall. This wall allows transfer of energy in the form of work to occur, but not transfer of energy in the form of heat. Again, we often consider this work to be expansion work, but again, any type of work may occur in an adiabatic system. You can learn more about thermodynamic work in another of these short videos. Since no energy in the form of heat can flow into or out of an adiabatic system, it may be that the system and surroundings are not in thermal equilibrium with each other and therefore at different temperatures. These four types of thermodynamic system all behave slightly differently from each other, and so it is important to be aware of what type of system we have when approaching problems in thermodynamics. So, in summary, an isolated system allows no transfer of either matter or energy. An open system allows matter to be removed or added, or energy to be removed or added. In a closed system, you cannot take away any material, but you can transfer energy in the form of either heat or work. And finally, in an adiabatic system, there can be no transfer of energy in the form of heat, but the system may do work on the surroundings or have work done on it by the surroundings. I hope that this video has proven helpful in detailing the different types of thermodynamic system. You will see their use in other videos. Thank you for watching, and if you have any questions, please do not hesitate to contact me.